Welcome. My name is Philippe Verzyp, and this webcast accompanies my book Data Analysis. In it, I will show you how to define a dummy variable and include it in your regression. When estimating regression, it's quite possible that we either want to isolate certain observations because they are quite extraordinary, or that we have data which comes in categories rather than numerical values. In both cases, we would like to use dummies. Now, a dummy variable is simply a variable that assumes the value of 0 or 1. To create one in eViews, we can use the generate function. It's a two-step procedure because first we want to generate a variable, say that I'm going to make a dummy which isolates the crash of 1987, which is present in this dataset. I call this new series crashDum, and first I set it equal to 0 for the entire sample. The reason is that if I don't do this, I get non-availables everywhere, almost everywhere, and that's not what we need. We need a variable which is either 0 or 1 and nothing else. Now, I have zeros everywhere right now, so that's not entirely what we need. We also need that the dummy variable assumes a value of 1, but only for the observation belonging to the 1987 crash. So that would be October 1987. We can do this in this way. We adjust the sample, and normally you give a begin and an end date, but if it's just one observation, those two are the same. I press OK, and after I've used the generate command for the second time, you can see, by the way, that if you open the series and go well to the right, there's another generate button you can use. But after we've done this, we see that indeed we have a 1, which is present at the right place, and the rest of the dummy consists of zeros. Exactly how we want it if we want to isolate this particular event. Now, the next question is, of course, how to include this in our equation. Suppose that we have the following equation, and I need to fix this to exclude prior dummies, I see. So we can start with a somewhat clean slate. Suppose that we have an equation where we have the size portfolio as dependent variable, a market, a fix, and a WTI as explanatory variables. That the numbering of the coefficients is a bit off now, doesn't matter. Actually, I need a bit of room to work with because now I'm going to add the dummy. Now I want to isolate one particular observation. If I want to isolate just one observation, then I can use simply an intercept dummy. I would not need a slope dummy, in fact that would be overkill. So to add an intercept dummy, I go to estimate, and then I add a part to the equation. In this case, C2 times crashDum. And I press OK again. The effect of this is that the observation of October 1987 is now completely isolated from the rest. Why? Well, it's one observation which would normally cause a very big residual. However, it has now got its own intercept. With its own intercept, you can draw a new line which goes straight through that observation, producing a residual of 0. So in effect, the residual of this particular month has been eliminated by use of this dummy coefficient. And therefore all the rest of the results are now free from any interference from the crash of 1987. The question is, of course, if you want to have this, if you want to explain how the market operates under normal circumstances, this will be a good choice. If you want to estimate a situation where you are looking at extremes of the market as well, you would like to have it included. Now this is only one aspect of dummies. It's also possible that the data comes in different categories. For instance, suppose that we want to isolate the effects when the VIX, the unrest on the market, is bigger than a certain value. Say that we want to isolate the situation where VIX exceeds the value of 30. But you can see that those correspond to situations where the markets are in great turmoil or are calming down from that. Again, the 1987 example is a good one, but the IT bubble, the first Gulf War, and some others are also present in this dataset. In order to do that, I need a new dummy variable. So once again, generate. I'll call this one just dummy. Dummy equals 0 for the entire sample. And then I open it again. I go to generate once more, and I put it equal to 0, but not for the entire sample, only if the VIX exceeds the value of 30. I can enter those if conditions in the sample. I press OK, and I see that indeed occasionally I get the ones. Not very many, but it happens from time to time. Now the next question is then how to incorporate this in my equation. I go back to the equation, estimate, and I'm going to remove that crash dummy, of course, but I need the new dummy. And this new dummy I would like to incorporate both as an intercept dummy and as a slope dummy, and therefore I need a couple of additions. The intercept dummy is now done, but I also need to add the slope dummy for the market, and for that we multiply the dummy with the market. This means that the influence of the market, so the influence of an independent variable, can be different if the VIX is high, so if the market is in turmoil. This actually sounds reasonably logical. We can also do this for the other independent variables, so we can also have an interaction with the dummy and the VIX itself, and with the oil price. In all those cases you multiply the dummy with the independent variable. That will produce a dummy variable for the slope. Once we estimate this, we see that the equation is now quite a bit bigger, and we have now in total 4 coefficients to investigate. Those 4 together give us the difference in relation between a market that is relatively calm, low VIX, dummy 0, and a market that's relatively in turmoil, VIX above 30. We see that we have a coefficient for the intercept dummy, which is quite high, but not significant. We have the coefficient C3 for the market. It's not very high and not significant either. We have C6 and C7, which are again not significant either. So it seems that this idea was actually not a very good one. If we want to know for sure, however, we would have to conduct an F-test, coefficient diagnostic wall test, where all the variables related to the dummy, so C2, C3 in this case, C6 and C7 would be equal to 0. In this way we can test if including the dummy would make any difference. And here we see that this null hypothesis is not rejected. So this particular split of the data, these in 2 categories, one with an agitated market, one with a non-agitated market, was actually not a good idea. This happens, but it is a nice illustration of how to work with dummies. Apologies for any computer glitches you may have caught along the way.